Welcome to Maths for You channel. There are a couple of questions from Sri Lankan A-level past papers. One is on graph sketching. The other one is on coordinate geometry. Let's start with the graph sketching. Just write the two function or two graphs. The modulus of two graphs, y equal 4x minus 3, the modulus 4x minus 3, and y equal 3 minus 2x. So this the graph for the modulus. I have the sketch, but do not look at the sketch now. This is the full sketch, but I just wanted to go through step by step to how I have achieved this graph for the modulus functions. So just to start with, take the first one, the modulus 4x minus 3. We know if the fx, say to call it fx, we call this one fx. If fx, just without the modulus, of course, fx greater than 0, so the above the x-axis or the positive side of the y, and the modulus is fx, just fx, the modulus fx, just fx. But if it's negative side, this fx less than 0, the below the x-axis, the modulus fx is minus fx, that is the reflection of fx on x-axis. So that is the starting. So I drew this the 4x minus 3 before. So that is just cut the x-axis at 304 because of 4x minus 3 equals 0, x equals 304. It cuts the x-axis and the y-axis. We don't want to know about that. Well, we will find out. So that is the normal graph. But the actual the condition that's property of the curves behaves is fx greater than 0, the modulus of fx is fx. So it just is from there to there. But anything less than or below the x-axis, it will be reflected to the positive side of it. That is minus fx. That is as the modulus of the whole function will represent. So just the anything when you draw the normal line, which is 4x minus 3, and if it's a positive side, just keep it like that. And if it's negative and below the x-axis, it will reflect to the positive side of it. This one, the point is 304 because of y equals 0. So 4x minus 3 equals 0. Therefore, x equal 403. Y, of course, 0. And if you want to do that, so 4x minus 3 is y, x is equal 0. So 4x minus 3 equal y. This is 0, so minus 3 equal y. But it's actually the minus fx, isn't it? So it's actually this from this to the left-hand side is a minus. So it's, of course, y is 3. This one, 3, 0. The coordinates of that is 3, 0, which we need to use it later on. Yeah. And that's about it. This graph. So just graph is the whole graph, the left hand side and the right hand side, of the red and black, are the modulus fx. So right, let's go to step 2. Step 2 for y equal 3x minus 2 mod x. I just want to start, sort of from the step with x modulus x. X, we just cross that, going from this, x, y equal x. But the modulus, as I said before, if it's greater than fx, so fx is x at the moment, x. If it's greater than fx is greater than or equals 0, x is same as x. So fx equal just x. But if it's less than 0, if it's less than fx less than 0, the fx is the minus fx, that is equal minus x. So simple as that. So just because of the reflection of x-axis, anything but. So it just, the vertex is 0, 0. Here the vertex is 3, 0, 4, 0. Now we have found this bit. So it's modulus x only we found. Then we go into that, the 2 modulus x. What that is a transformation. You just multiply by 2. Transformation. If it's a fx, it's vertical stretch by 2. So simply vertical stretch. You just pull it upwards. When you do that, then it will actually reduce that, the angle here will increase. So it will sort of get closer, like that. So that is, now it's 2x and minus 2x. So just, in other words, the gradient increase for those two lines. Right, that's done. Now go for minus. We have minus. We just do that. So minus fx mean it's simply a reflection of x-axis. So just what we have here on step 2, step 3, just a reflection of x-axis. That will be here. So 2x become minus 2x, minus 2x become positive 2x. Is a transformation, say fx plus a. The transformation is the vector multiplication, the 0 over 2. So in other words, the y coordinates will increase. So when you do that, it will increase. Here, minus, right, no, that's here, sorry. X plus a is here, right. Okay, x for fx plus a, just addition number. So what we need now, we are looking for 3 minus 2 mod x. So minus 2 mod x, the yellow graph. Now 3 minus mod x, just to push it, you move the whole thing to 0, 3, because of a's, a here is 3. So it's transformation by vector a0, transformation by vector a0. So it just it will move upwards to along the y-axis here. So it's 0, 3, from 0, 0 to 0, 3. So this is the 3 minus 2x and 3 plus 2x. That's simple as that. So done. Both graph is be done. So now I'm going to go back to the full sketch. So the question is draw both modulus function on a same graph. So we have done it. We proved it, or we actually went through the step by step how we achieved this. This is what it is. And then again, of course, the two, if we could work out the two, the graphs is intersects here. And then if we work it out, it's just 4x minus 3 and 3 minus 2x, and work it out is 1, 0. Of course, the 3 minus 2x cuts the x-axis. Therefore, y equals 0. That is 3 over 2, 0, 0. All these we can work it out. So I don't want to sort of wasting time going through all that. So we have found this graph on a same diagram, both modulus function. Well, first one is fully modulus, other one is some function and modulus. So both graph on a single same xy axis. That's done. So Now, let's look at that. If you look at this diagram, it says what we have asked the next question. Let me read that. The next one, hence or otherwise, find all the real values of x satisfying the inequality, the modulus 2x minus 3 plus modulus x less than 3. That condition. Right, okay, let's look at what we have at the moment. We have, we don't have 2x minus 3, we have 4x minus 3. So 4x minus 3, this graph, the black one, and the 3 minus 2x is the red one. So the red one greater than the black one is only here only. So in other words, from 0 to 1. So that is the only place where red one is greater than the black one. The rest of areas, the black one is greater. So what we need to know, the less than the one. So let's see that. Right. Okay. I just took the sort of simply that part which we explained. Here is just a green line. So that is the line is greater than the black. 4x minus 3 greater than. But what with yeah, this is I just found the value for x and x1 y1 intersect values. Right. We have the actual original graph 4x minus 3 and 3 minus 2 lambda x. So as I said, the green part of it only that the red line or the graph is greater than the black graph. So 4x modulus 4x minus 3 less than 3 minus 2 modulus x. This is purely from the graph, and I just rearranging it, took 2 inside just to simplify it. So this is we know from the graph, but the question we asked different. But let's go for it anyway. So what I did actually, I took the minus to this side. So this is inequality, almost like equation. So I just bring it to that. This is what we have. If you look at it, the range or the x value is simply from there to there. So 0 to 1. That's what it is. X is less than 1, but greater than 0. That is only 1. But that's not the question we've been asked. We asked something else. But we know another property. If fx and if ax is what will happen if it's fx there, and if ax means it will stretch horizontally along the x-axis by 1 over 8. If it's 5, it's 1 over 5. If it's 6, 1 over 6. What we need is 2x minus 3. So in other words, half of that 4x, isn't it? So it just surely we need to divide by. So it's multiplied by half, not a is half. A equal half. If that's the case, we see here the half x. So just x part is 2x minus 3, and here 2 is gone, x. And I just took it purposely minus 3 as a function, not using that inequality yet. So that now we have come, what it is stretch. When it's stretch by 2, stretch by 1 away, I mean half, if a is half, and the stretch by 2. Stretch by 2, the 2. So that means before the value here is 3 over 2. This is 3 over 2. Now it's double. So therefore it's 3 and 0. And before this is 1, 0 and 0, we have that range. We just wrote it here. Where is it? Here. Wrote it here. So 1 and 0. Now is 1 is stretched by 2. So that is become 2 and 0. So the range. So if 3x minus 3 plus x modulus x, modulus 2x minus 3, modulus x less than 3, the range would be 0x, x is between 0 and 2. Before that, now it's stretched by 2. So this is the answer. So the first question is done. I just went through step by step to explain more. Right. Look at the second question. Let L1 and L2 be the straight lines given by x plus y equal 4, 4x plus 3 equal 3y, 4x plus 3y equal 10, respectively. The two distinct points P and Q are on L1 such that the perpendicular distance from each of these points to the line L2 is 1 unit. Find the coordinates of P and Q. Right, okay. First of all, there are two lines. And there are 2 points on that one line, L1. And from that line, perpendicular distance to the other line is 1 unit or equal and 1 unit. So if a point from one line to another line the distance from a point from one line to different points, another line are equal, that means those two lines are parallel. See whether they are parallel. No, the first equation L1 x plus y equal 4. The gradient of that is minus 1. 4x 3y equals 10. So of course the gradient is 403. So it's not equal. If it's parallel, the gradients should be equal, but they are not. So only other option, they should cross each other. So I just crossed it. L1 and L2, and P and Q are 2 points. I took P coordinates, x1, and I didn't put y1. I put in the x1 format because we know the equation. X plus y equal 4. Therefore, y is 4 minus x. So that means 4 minus x1. The same thing, Q, x2, 4 minus x2. We know it's a standard property or equation or formula, whatever you want to call it. From a point to a straight line, a perpendicular distance from a point to a straight line, there is a formula. That is, I just put to say if it's a line is ax plus by plus c equals 0, as point x1 and x2, the d is the distance from that perpendicular distance. D equal the modulus, because of its distance always positive. The modulus ax1 plus by1 plus c divided by a squared plus b squared. That's the standard formula. I'm going to use that because we have two perpendicular distance or perpendicular, which are units. So perpendicular distance from P to start with, that is 1. We have given 1 unit. And same equation is substitute that so 4 times x1 plus 3 times 4 minus x1 minus 10. Because of when you bring that 10 to left-hand side, it's minus 10. And square root of 4 squared plus 3 squared. And 4x squared, 4 times 3 is plus 12, 3x1 minus 3x1 minus 10 divided by 5, because of 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, root 25 is 5. Right. And again, there is no plus or minus business here. It's distance, always positive. So from that, if you 4x1 minus 3x1 is x1, and 12 minus 10 is 2. So x1 plus 2 is 5. So x1 is equal to 3. And then we can work out the y coordinates, which is 4 minus 3 equal 1. So the coordinates of P is 3 and 1. Then because of this L1 and L2 cross, we just said it as cross. When it cross at R, we can find the coordinates as simple. So the first equation is 4x plus 3y equal 10, which is what the L2. The other one is x plus y equal 4, equation 2. Then if I multiply equation 2 by 3, 3x plus 3y equal 12, equation 3. Then 1 minus 3, equation 1 minus 3, 4x minus 3x equal x. And 3y cancelled out. 10 minus 12 is minus 2. That is the x coordinate of then the y coordinate is exactly, or q, of course. Y coordinate is simply, we know that here is 4 minus x. So 4 minus, sorry, here. So 4 minus 2 is plus 2, is 6. So 4 minus 2 equals 6. So 6. That we have found, so that x and y of that the line, I mean point of intersection, that's done. Right. We know if you look at these two triangle here, this perpendicular 90, this is equal, these two angles are equal, therefore these two triangles are coherent triangle, therefore pi equal rq. So we know pi equal rq. From that coordinates of p and q in the form of x1 and x2, the midpoint we can find, which is x1 plus x2 over 2. That is, we already found minus 2. From that, x1 plus x2 is minus 4. X1 is, we know, is where is it? X1 is 3. Yes, the p coordinate, x1 is 3. If you substitute that, x1 is 3, x2 is minus 7. And then, of course, is 4 minus 7 is 11. So that is q, coordinates of q. This is coordinates of p. That is exactly what we have been asked to find. Find the coordinates of p and q. Yes. Thank you. Please subscribe the channel and share the contents with your friends and other students. If you want, you can put it on Facebook or something, your Facebook or something. People can benefit from this if they may. Thank you.